Imagine visiting Earth 100,000 years ago. We would see forests and savannas teeming with life, millions of species of every shape and size. But among all the 8.7 million species on the planet, not one was building fires or painting on cave walls. Fast forward to today, and one species has split the atom, walked on the moon, and is currently asking why it's the only one to do so. How did we, humble Homo sapiens, get so smart, while our chimpanzee cousins still forage for fruit and no dolphin debates the meaning of life? Why only us? Was our intelligence an inevitable step on life's journey, or a cosmic fluke, a lottery that nature almost never wins? These are the questions that pull us into one of the deepest mysteries of our existence. To be clear, humans aren't the only clever creatures. Far from it. Crows craft tools from twigs, octopuses solve puzzles, chimps use sticks to fish for termites. Intelligence, in some form, sparkles throughout the animal kingdom. Yet, human intelligence is on a completely different scale. We write symphonies, invent mathematics, and imagine galaxies light years away. No other species even comes close. Of all the evolutionary experiments in cognition, only one resulted in a species that can contemplate evolution itself. This stark fact begs a question. If a big brain is such a winning strategy, why didn't any other species evolve one? It turns out that our level of intelligence might be less inevitable and more extremely improbable in evolution's playbook. In nature, evolution often repeats itself. Different animals arrive at the same solutions by independent paths. Think of how both dolphins and ancient ichthyosaurs evolved sleek bodies to cut through water. But human-like intelligence never cropped up twice. There were marsupial wolves and marsupial moles that evolved to fill predatory and burrowing niches on their own, but no marsupial humans. In over 4.5 billion years of Earth's history, a brain capable of rocket science appeared just this once. If intelligence were such a straightforward advantage, we might expect to see it evolve again and again. Instead, it seems our evolution was like hitting the jackpot, not once, but repeatedly. The conditions had to be just right, and each of several unlikely innovations had to line up in our lineage to produce minds as capable as ours. In the cosmic casino of evolution, intelligence might be one of the rarest wins of all. So what made the human line hit that jackpot? Why us, and not the clever crows or the resourceful dolphins? To unravel this, we need to explore the perfect storm of challenges and opportunities that sculpted our ancestors' brains. It's a tale of trade-offs and gambles, of cooperation and competition, of fire and talk and even love, all unfolding over millions of years. First, consider that big brains don't come free. Your brain is a hungry organ. It's about 2% of your body weight, but devours 20% of your resting energy. Basically, 1 out of every 5 calories you burn. A chimpanzee's brain uses roughly half that energy. This biological fact hints at a hard truth. In evolution, you can't get something for nothing. Our ancestors' bodies had to pay for our powerful minds. How? Trade-offs. Over time, humans became surprisingly weak for an ape our size. A chimpanzee is twice as strong as a comparable human. We also have smaller guts than would be expected for a primate of our stature. These changes aren't coincidental. They're the price tag of our braininess. Scientists call this the expensive tissue hypothesis, the idea that to afford an energy-guzzling brain, our lineage had to cut costs elsewhere. Smaller intestines and weaker muscles freed up calories to fuel our growing neurons. Fossil evidence and genetic studies actually back this up. In our evolution, genes that allocate energy between organs shifted in a way that favors brain over brawn. We quite literally reallocated resources to feed our thoughts. But even with belt tightening in the gut and muscles, an extra-large brain still needs lots of energy. How did our ancestors find the nutritional budget to support it? One compelling theory points to a humble spark: fire. When our forebears learned to tame fire and cook food, they unlocked a bounty of calories. Cooked meat and tubers yield far more energy and are easier to digest than raw fare. As anthropologist Richard Wrangham argues, Cooking might have been crucial in permitting a bigger brain budget. Soft cooked foods meant we could afford to shrink our guts and spend those calories on our brains instead. In essence, the campfire not only kept predators away, it nourished the intellect growing behind our eyes. Next time you're enjoying a hot meal, consider that without that ancient innovation, your brain power might literally still be half-baked. There's also the matter of time. Brains aren't just costly to run, they're costly to grow. Human children are born helpless and developmentally unfinished, because if we waited until our brains were fully developed, no mother could survive giving birth to such a big head. Instead, we're born early, essentially premature apes, and require years of growth and learning outside the womb. Our childhood is extraordinarily long. Human kids depend on parents for a decade or more, whereas young chimps can fend for themselves much sooner. This long childhood is another price of high intelligence. It only could have evolved if the benefits later in life outweighed the huge risks and burdens early on. Think of it as a high-risk, high-reward investment. Spend extra energy and time raising a slow-maturing baby, but end up with a capable, intelligent adult who might change the game for your whole community. Surviving as a fragile, big-brained ape baby is no easy task. And that leads us to another critical piece of the puzzle. We didn't get smart alone. We had each other. Humans are ultra-social animals. We live in groups, we help each other, and we pass knowledge down through generations. Many scientists believe that our intelligence is fundamentally a social intelligence, forged in the fires of communication, cooperation, and yes, competition among individuals. One classic idea, the social brain hypothesis, suggests that our ancestors' brains grew large to handle the demands of living in complex social tribes. To thrive, you had to remember who was generous and who was selfish last season, how X is related to Y, who might deceive you, and how to keep favor with the alpha hunters. Outsmarting your peers, and occasionally cooperating with them, became a matter of life and death. In a sense, humanity's first chessboard was the social group, and the moves involved alliances, reputations, and grudges. This hypothesis is compelling. After all, primates with larger brains often live in bigger social groups, but it raises a thorny question. If social life makes you smart, why aren't elephants debating philosophy or meerkats doing mathematics? Plenty of animals, like meerkats, have intricate social lives, yet never took an intellectual great leap forward. Clearly, social complexity alone wasn't enough to spark our level of intelligence. Something else was needed, something that set our ancestors apart in their social evolution. Anthropologist Richard Alexander offered an interesting tweak. He proposed that our ancestors first had to master their environment, to dominate their ecology, before social challenges could really crank up our brain power. In other words, as long as you're constantly starving or being hunted by lions, there's no evolutionary timeout to have a battle of wits with your neighbor. But once early humans, with tools, teamwork, and maybe some fire, started to solve the basic problems of survival, secured food, fended off predators, natural selection's spotlight could shift inward towards competition within the species. The struggle for survival became a struggle for status, mates, and influence, a Machiavellian intelligence arms race where the sharpest mind often won. According to this view, only humans reach that stage of ecological dominance where the brain could be honed by social one-upmanship. Crucially, traits like free hands, thanks to walking upright, helped our ancestors dominate their environment early on, wielding tools and weapons, which then let social chess replace outrunning leopards as the driver of evolution. There's another side to the social coin, though. While we certainly competed with each other, we also learned to cooperate in unparalleled ways. Humans aren't the only cooperative animals. Wolves hunt in packs, ants build colonies. But we took teamwork to another level. We share food, adopt orphan children, care for the sick, and communicate about things that aren't even present. There's a herd of bison beyond the hills. Let's plan a hunt. We even cooperated across family lines, which is rare in nature. In many social animals, only the alpha pair breeds, and others help, like those meerkats who babysit their sister's pups. Humans are unusual. Anyone, in principle, can have a child, and others in the group still help raise that child. Uncles, friends, grandparents. We developed a whole network of care that blurs the lines of whose offspring is whose. This village approach to child rearing might be a key to our success. Big brains are hard to grow. It likely took a tribe to raise a genius. By sharing the burden of parenting and protecting each other, our ancestors could afford to invest in the next generation's lengthy learning and development. To coordinate such cooperation, another breakthrough was needed: communication. Our ancestors started to share knowledge and intentions through language, and not just simple signals, but symbolic language, words that stand for ideas. Only humans, and our extinct close relatives, developed the trick of assigning names and abstract meanings to things. This was huge. With language, we could tell each other about the past, plan for the future, and teach lessons and skills with precision. We began to connect individual brains into a collective mind, accumulating knowledge over time. The invention of language is like giving our intelligence a multiplier. Suddenly, no single human had to figure everything out from scratch. We pooled our smarts. Think about the power of that. One person discovers how to make a fire, and through teaching, every member of the tribe can have fire. One wise grandmother remembers a drought decades ago and warns the group when the birds and wind signal another dry spell coming. Disaster is averted thanks to shared wisdom. Even something as simple as names, calling someone friend or uncle or chief, builds social structure out of thin air, using agreed-upon ideas instead of instinct. We don't often appreciate it, but symbolic thought is basically mental magic. It allowed humans to create invisible institutions like kinship, clans, or eventually nations and companies and religions that coordinate behavior on massive scales. Other species live in the here and now, but language let our ancestors live in history and imagination as well, discussing myths, imagining spirits, devising rules. Our intelligence expanded into these socially constructed worlds, growing deeper and more nuanced. So perhaps one answer to why only humans is this: we evolved the rare ability to truly share knowledge and work together flexibly beyond immediate kin. We became smart because we became so social, and being smarter further turbocharged our culture, which made us even more cooperative and inventive. It's a self-reinforcing cycle, one that no other creature on Earth got into quite like we did. Still, social life and energy-rich food might not tell the whole story. Our evolutionary journey was also shaped by environmental chaos. The world changed around our ancestors again and again. Ice ages came and went. Jungles turned to savannas, then back to forests. In Africa, where our lineage arose, climate shifts would have forced populations to adapt or die on a frequent basis. Some scientists suggest that this climate instability favored the evolution of a flexible problem-solving mind. In a world that wouldn't sit still, the creatures that could think on their feet, or think on their hind legs as it were, had the edge. An ape that could survive both drought and flood, that could figure out new foods when the old ones vanished. That ape would thrive where more specialized creatures might perish. In this view, intelligence is the ultimate generalist's tool. Instead of being hyper-adapted to one environment, be adaptable to any environment. As the saying goes, intelligence is the ability to adapt to change. Over millennia, the hominins, human ancestors, who could innovate, make a new tool, explore a new territory, devise a new hunting strategy, would survive the curveballs nature threw at them. Yet, other animals faced climate upheavals too, and didn't build rocket ships. So there must be something distinctive that let our ancestors capitalize on their smarts. One practical factor was likely our hands. Humans evolved free, dexterous hands with opposable thumbs, thanks to walking upright. We could grasp, tinker, and build like no other creature. Intelligence alone doesn't invent the bow and arrow. You need hands that can shape the wood and string it. Many intelligent animals are limited by their lack of hands. A dolphin may be as smart as a toddler in some ways, but without fire or tools, and living in water, it had no path to a technological civilization. Only humans had the brain and the manual ability to turn thoughts into material reality. Those two in combination set off an evolutionary wildfire. The more we used tools, the more useful a bigger brain became, and the bigger our brains grew, the better we got at inventing new tools. It was a feedback loop stretching over hundreds of thousands of years. Stone axes to spears to sewing needles to boats, each innovation rewarding those capable of learning and improving it. We became tool makers and tool users without parallel, and the world yielded to our clever hands. In short, we hacked the system. Instead of waiting for evolution to give us a thicker fur coat, we could sew animal skins. Instead of evolving night vision, we could craft a torch. This ability to manipulate our environment gave us a tremendous advantage and reinforced the evolution of intelligence itself. Now there's an intriguing and somewhat provocative theory that adds a different twist. What if our intelligence wasn't really about survival at first, but about showing off? Enter psychologist Jeffrey Miller's idea of the brain as a sexual ornament. He suggests that much like a peacock's tail, beautiful, costly, but used to attract mates, our big brains and the behaviors they enable, art, music, witty conversation, might have initially been driven by sexual selection. In other words, perhaps having a fantastic mind made our ancestors more attractive to each other. Think about humor, creativity, or eloquence. These don't directly help you survive a thunderstorm or kill a deer, yet humans everywhere find these traits appealing in mates. Miller argues that if you can not only survive, but do so while carrying the excess baggage of a large, energy-hungry brain, it signals you have good genes and abundant resources. By this logic, braininess itself became sexy. Our ancestors might have selected partners who could tell the best stories, sing the most soothing lullabies, or invent the coolest new gadget around camp. Over time, courtship of the clever led to ever cleverer apes. It's a somewhat romantic idea that we loved our species into intelligence, and while it's hard to prove, it adds yet another dimension to why only humans reached this pinnacle. Survival of the fittest, yes, but also perhaps survival of the wittiest. Why didn't other species match us? Even understanding all these factors, energy trade-offs, social complexity, language, tool use, environmental challenges, maybe even sexual selection, we might still wonder why no other species hit the same jackpot. The Earth is rich with life. Why didn't elephants or parrots or Neanderthals end up building cities too? Examining these cases can be illuminating. Take our close cousins, the Neanderthals. They actually did have large brains. In fact, Neanderthal brains on average were as big as or even a bit larger than modern human brains. They used fire, made tools, and survived harsh Ice Age climates in Europe and Asia. And yet, after coexisting with humans for millennia, they went extinct around 40,000 years ago, shortly after we, Homo sapiens, arrived on their turf. Why? One theory suggests their brains, while large, were organized differently. Research indicates Neanderthals devoted more of their brain to visual processing and bodily control, perhaps to deal with low-light winters and their heavy musculature, and correspondingly less to social cognition. In plainer terms, we think Neanderthals may have had less capacity for large social networks and innovation. A study comparing their skulls to ours concluded that, once you account for their bigger eyes and bigger bodies, Neanderthals had less brain volume left over for complex thinking and social interaction. They likely lived in smaller groups, with fewer friends to turn to in a crisis, fewer opportunities to learn from a variety of peers. Meanwhile, Homo sapiens, possibly thanks to African origins requiring more social cooperation or maybe a lucky genetic spark, developed richer social lives, broader trade networks, and more rapid cumulative innovation. The result? When times got tough, we had the social and mental agility to adapt and tap distant allies, and Neanderthals apparently didn't. Our smarts were wired for connectivity and creativity in a way theirs might not have been, and that may have made all the difference. What about other very intelligent animals alive today, like dolphins or elephants or crows? They each illustrate a different ceiling that they hit. Dolphins, for example, have complex communication, can recognize themselves in mirrors, a sign of self-awareness, and live in intricate social groups. But living in the ocean imposes limits. They can't manipulate objects easily with flippers. They can't control fire or craft durable tools underwater. Their environment may simply lack the kind of challenges that spur technological intelligence, or it denies them the means to act upon their intelligence in world-changing ways. Elephants have long lifespans, strong social bonds, and great memories, all promising ingredients for high intelligence. But again, lacking fine manipulators, their trunks are amazing but not as versatile as hands. They never entered the same feedback loop of tool use and brain growth. They also satisfy their needs pretty effectively with their existing behaviors. There may have been less pressure for an elephant to become an Einstein-esque problem solver when being big and social was enough. And crows or parrots, some of the smartest birds, are remarkable in cognition. Some can use tools or understand rudimentary human words. But birds have their own constraints. A bird's brain, while efficient for its size, is physically much smaller than a mammal's due to flight weight limits. They also don't have hands, though some use their beaks and feet quite cleverly. So while they achieved a lot, tool use, social learning, their evolutionary path had different trade-offs. In each case, we see that intelligence isn't a single trait that inevitably rises given enough time. It's an expensive, risky strategy, and unless a whole suite of other circumstances align, right anatomy, right environment, right social structure, evolution tends to find easier solutions. In fact, some scientists argue that the conditions needed for human-style intelligence are so unusual that they almost never occur. If evolution is a tinkerer, high intelligence might be its most baroque, complicated invention, one that it resorts to only under rare circumstances. The drawbacks of a big brain can nullify its advantages in many cases. A monkey that's 10% smarter but needs 20% more food might starve in a drought while its slightly dumber cousin lives on. So unless that extra smarts provides a critical edge, natural selection won't preserve it. Intelligence might often not confer an immediate evolutionary advantage. It's more like a long-term investment. For us, that investment paid off spectacularly, but it required a confluence of factors that is truly rare. So here we stand, Homo sapiens, the lone species, as far as we know, in Earth's 4+ billion-year story that achieved this extraordinary level of cognition. We've tried to unravel how it happened. The caloric windfall of cooking and other metabolic trade-offs that powered our brains, the social crucible of cooperation and competition that sharpened our wits, the environmental roller coaster that rewarded adaptability and innovation, the manual dexterity that let us translate ideas into tools and technology, and perhaps even the whims of sexual attraction that favored creativity and intelligence as desirable traits. It took all of these, and a fair bit of luck, to break through the ceiling that held every other species in check. Yet, despite all we know, there's a lingering mystery. In the final calculus, why us? One could say simply, why not us? Given enough time, someone had to win the evolutionary lottery, and it happened to be our ancestors. If you reran Earth's clock, maybe intelligence would arise in some other lineage, say, clever dinosaur people evolving in an alternate timeline where an asteroid never wiped out the reptiles. Or maybe not. Maybe if we started over, we'd find no species ever gets to this point again, and the Earth would be forever a planet of brilliant beasts that never quite break through to self-aware civilization. Either way, we are here now, asking the questions. We're the universe's first known experiment in matter that can question itself, and that is both thrilling and sobering. On one hand, it makes us special. We hold within our skulls secrets that took eons to forge. We are, in a very real sense, nature become conscious of itself. On the other hand, it's a reminder of our fragility. Unique does not mean invincible. Intelligence gave us power, but it also gave us the capacity to shape our world for better or worse, even to endanger ourselves. If we truly are such an improbable occurrence, we should perhaps treasure what we have, this spark of insight, and use it wisely. In the silence of the cosmos, human intelligence might be a lonely light. Are we truly alone in this vast universe as thinking beings? Science hasn't found anyone else yet, and it's possible that the evolutionary hurdles for intelligence are so high that they've only been cleared once, right here, by us. Then again, the universe is immensely large. There could be other lights out there, hidden by distance or time, other species that beat the odds on their own world. We simply don't know. What we do know is that on Earth, intelligence had to fight tooth and nail to emerge. It's a hard-won gift of evolution, paid for by sacrifices and cooperation, by fire and blood and curiosity. Only humans got this smart, but now that we are, the future of that intelligence is in our hands. Will we use it to illuminate the world or to burn ourselves out? That is, perhaps, the next evolutionary test. For now, as you ponder these words, you, a human mind, are engaging in an activity unlike anything else in the living kingdom, reflecting on your own origins and purpose. Of all the stories told by rocks and fossils, ours is the only one told by the storyteller itself. In that fact lies a profound wonder. Evolution, blind and unguided, somehow evolved a being that can understand evolution. The child has grown enough to gaze back at the parent. Why did only humans get this smart? We may have answered in part with science, a confluence of diet, society, environment, chance. But there's also a bit of poetry in the answer. Perhaps it comes down to this. We became intelligent because the universe needed eyes and ears and minds to witness it, and it rolled the dice until one species could. Perhaps intelligence is just one of nature's rarest flowers, blooming only under the most exceptional conditions, and in us, it finally bloomed. The true magnitude of that achievement is something worth marveling at. So the next time you look up at the stars, or solve a puzzle, or share a story with a friend, take a moment to appreciate the incredible lineage of events that made it possible. One lonely, curious species, out of millions, beating the odds. It's enough to give you chills. In the grand tale of evolution, our chapter, the chapter of mind, is a plot twist billions of years in the making. And we're all heirs to that wondrous twist, living it each day and hopefully carrying it forward into chapters yet to come.